Welcome back everyone. In this video, we are going to discuss about compound interest. So this video's topic is compound interest. But before I begin, you guys should already have clicked on this link and done your mandatory reading. If you haven't done so, please pause the video, click on the link and spend about 10 to 15 minutes first, understand the concept, read about the concept, and then come back and watch this video. So if you click on the link, this will take you to a MathSpace page where you can see the details of compound interest. So maybe I'll try to explain how the formula comes, and then you guys can go ahead and solve few problems, because using the formula is not a big deal, but in order to understand how the concepts of the how the formula is being formed sometimes give you insights, otherwise you will not know. So let's take an example. Let's say you put some money in the bank, and we call it, let's say, P. We are calling it P. In other words, this is the principal amount of money. In other words, in the formula, you see here, A is accumulated, P is principal, R is interest rate, and N is number of periods. But we'll get to the formula later. For example, you put some money P, and end of the year with the interest rate R%, let's say that's your interest rate. What are you going to get? You're going to get your P amount of money plus the interest. But how much is the interest? P into R%. So overall, what you're going to get is P plus PR, whatever the interest rate is. In other words, end of the year, you're going to get 1 plus R. So that's your amount of money end of first year. Now, if it keeps accumulating, and that's where the A comes in. So A is the accumulated fund. So it's the final amount of money after a certain period of time, given certain interest rate and given certain number of years you want to put the money in the bank or whatever. That's the total amount of money given at a particular time, given number of periods and interest rate. So what's going to happen second year, end of second year? So end of second year. So think of this as at the beginning of second year, you have this much money. So that's your new principal. End of the year, what's going to happen? You're going to have this much money plus you're going to have R%. So this is your interest of the end of second year. So this total is going to give you money after second year. So look what's happening here. If you take P1 plus R common, what do you have? 1 plus R. So then 1 plus R and 1 plus R is simply P1 plus R squared. So this is money after second year. This is money after first year. Now I can go ahead and do A3, A4, but I'll just, for the sake of the video, for making the video a bit shorter, I'll stop at that. But you can already see one thing, which is these powers are increasing. So this was 1 and this is becoming 2, and I can already see that A3 is going to be simply P1 plus R3 here, and dot 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 dot. If I continue up to nth year, it's going to be P1 plus R to the power n, and that's your compound interest formula right here. So I think that's enough of an idea where it comes from. If you want to know details, Google it. There is plenty of videos where you will see it shows the whole derivation. But we are not interested in derivation at this point. I just wanted to show you where it comes from so you have roughly idea where you need to look for if you are interested into the inner intricacies of the mathematics. Now let's get into more practical problem solving skills. So what we do. So the accumulated fund is P1 plus R to the power n. So you already know what the terms are. This is accumulated fund. This is your principal amount that you start with. This is your 1 plus R. In fact, this is your interest rate. So sometimes the word is per annum or P dot A. This is same thing as saying per year. So don't get confused. And this is number of periods. Now see, we are not saying number of years, we are not saying number of months, we are not saying number of quarters, but we are saying number of periods, and that is very crucial. The crucial part here is to understand that whatever this is, this must be consistent. In other words, if you are charging interest per year, number of periods must be in year. If you are charging interest per month, number of periods must be per month. So they can't be different. So your interest can't be, let's say, 6% per year and then number of months for n. It has to be number of years for n as well. And there is another complicated addition to it, which is what if, like number of periods and interest rate is not the same, and it's not synchronous. So what do we do? So we can write the formula in a more detailed format where this is interest rate, this is divided by n, and this thing becomes nt. So this still becomes number of periods, which is consistent with that, and this t gives you time. So in other words, nt together will give you total number of periods. Let's say quarterly for 4 years. So it's going to be 4 multiplied with the 4, which is 16. And in the same breath, your R is going to be quarterly if you do this. So if you, let's say 6% per year, if you divide 6% per year with, quarters, so that's going to be 3 by 2 percentage quarterly. And NT will give you quarterly. So that way it's taken care of. They are always in sync. So always use this formula when you do calculations so that your interest rate and number of periods, they are always in sync. But always make sure uh, to understand what is number of periods and how the questions are given. Once you do a few problems, I think you'll get used to the concept of bringing them on the same time frame. So that's all about compound interest. I wanted to just as well touch onto something else at this point, which was missed in the last video. So all of you remember y equals to a to the power x. We could convert this exponential to logarithm, which is x equals to log a y. But I missed out on something, a special kind, which is this a can be anything. This a can be anything. 1, 2, 3, 4, 5, whatever, minus 1, 2, 3, 4, 5. But there is a specific one, which is e. So y equal to e to the power x. So this e is natural logarithm. So we'll know a lot more about it next week. But as of now, just understand that e is a special number, and in place of a, if we replace by e, this becomes x equals to log ey, and then log e has a special name called lny. So log e, log base e, is named ln. So in other words, it's pronounced as lawn, ln, but it's written as ln. So if we have any base e or nothing is given, and it's just written x equals to ln y, you automatically know the base was e. So I just wanted to touch base on that as well. So that's all from me for compound interest. I'll see you in the next video. Oh, before I finish, so what you guys should do is go through the few problems, go through the lesson first, and go through, sorry, go through the few problems that's here. There are worked out problems. Go through them, understand them. If you don't understand them, watch the video, and then when you are confident, as usual, go try a few questions before you head to the next concept. And thank you. I'll see you in the next video.